Hey there, so we've talked about the constant of equilibrium. Now, before we move on and we apply this constant concept to specific substances such as acids and bases, we need to review the concept of acids and bases. So what makes a substance acidic? What makes a substance basic? So the theory that you saw last year is that an acid is an H plus donor and a base would be an OH negative donor. So a base, an alkaline substance, produces an OH minus ion, and an acid produces an H plus ion. So for example, if we look at the following reactions, we have HBr, which is an acid we know because it starts with an H. When it dissociates in water, it would produce the H plus ion, and the other half would be the Br minus ion. If we have H2SO4, we would have an H plus that is released, and the rest of the molecule, HSO4, that would have the minus sign. It carries the charge of -1 to balance out the plus sign over here, the positive charge. Same thing for the third example. Now for the base, we have a metal normally with an OH ion. So when this dissociates, it produces a positive ion, a cation, and the typical OH minus ion. So LiOH would give you Li plus and OH minus. KOH would give you K plus and OH minus. So you learned that last year. Now in the case of neutralization, we have an acid. So I put the H in color to show that it's an acid. It starts with an H. The base ends with OH typically. Now, when we put those two substances in water and we put them actually together, what happens is that they both dissociate and produce ions. Those ions reconnect together to form water. So the H from the acid and the OH from the base will combine together to produce the water. And the other two ions left, Cl minus and Na plus in this example, will combine to form a salt. Now the problem with this situation or this theory is that it's limited. It doesn't explain certain observations that we can make in reality, in a real neutralization or a real situation. So what is unaccounted for is the following. Sometimes we have what we call H3O plus ions or hydronium ions that form when a water molecule combines with an H plus from an acid. So this theory that I've talked about and that we covered last year with you does not explain where this ion comes from, and it's fairly common actually. It also doesn't explain the basic property of certain substances that do not contain an OH ion within the molecule. So certain substances are basic, have those qualities, but don't contain an OH part, and we can't explain that based on this theory over here. And lastly, sometimes you can have neutralizations that don't occur in a water environment, in an aqueous environment. We only saw aqueous environments so far, but it's not always the case. So how do we explain those neutralizations that don't happen in water? Well, again, this situation, this theory does not explain that. So we're going to have to move on to a second theory, which is the Bronsted-Lowry theory. So last year's was the Arrhenius theory, and now we're adding the Bronsted-Lowry theory. So what these two guys say, or said, is that an acid is a proton donor. So it does give an H plus, but a base, rather than giving off an OH minus, will actually accept that proton. So it's a proton acceptor. So this theory takes into account the fact that bases don't always contain an OH, but also can explain why or how certain reactions, neutralization reactions, do not occur in an aqueous medium. So we have an example here of a reaction that does not involve a typical acid and base as we know them, and that does not happen in a water medium. Actually, there is water involved in this reaction, but it's actually a reactant. It's not only the medium. So we have a base over here, an H3, ammonia, which is a base, but again, doesn't contain an OH part to it. And it reacts with a water molecule, and that will play the role of the acid. So this base reacts with this, which is technically our acid, to form ammonium and an OH minus ion. So in this theory, my NH3 gained an H to become NH4 plus. So because this substance gained an H, well, this will be labeled as my base, because if you remember, the base gains an H plus, and the water gives off an H plus. So H2O became OH minus. So because it gave off an H plus, this will be considered my acid, again based on this theory. Now, if we look at the counterparts, the products, we could have a reverse reaction whereby this guy over here has an extra H plus. So because it has an extra H plus, it would be able to give off an H plus, making it an acid. And this guy over here, being negative, would be able to accept an H plus, making it a base. So we pair up substances in reactions like this. So this H2O became OH minus. Now on this side of the reaction, it was the acid. On this side of the reaction, it became the base. So this pair, acid-base, are called conjugates. Or this is the conjugate base of this acid. If we look at the other pair, the base over here had accepted an H plus to become NH4 plus. So this one is a base paired up with an acid on the other side, which would be an acid. So because they're from the same family, so to speak, but one is an acid, the other one is a base, again, we call them conjugates. So it's the conjugate base acid pair, the same way we have the conjugate acid base pair. And that's all there is to this section. So I'll see you for the next one, 12.2.1.